Companies come to me with a lot of different reasons to adopt the cloud. Usually, they want to adopt some kind of managed service. And why wouldn't they? Most companies want to focus as much of their time as possible delivering new functionality and features. And since a lot of cloud vendors will say, you pay us and we'll provide you a reliable platform, a lot of companies end up taking that deal. But what we often don't understand is how reliable those services will end up being. So today, I want to focus on figuring out how your design choices affect your overall composite SLA, or service level agreement. Then I'll provide a practical example on what you can do to improve your overall reliability. Then I'll provide a practical example on how you can improve your overall reliability, along with some of the gotchas you'll encounter along the way. A couple of caveats. Number one, a lot of this is hypothetical. SLAs are not promises, they're obligations. They're not always met. Two, we're focusing on Google Cloud today. It's what I spend most of my time working on, but all of the lessons will carry over to any cloud vendor. With that said, let's get into it. Let's start with a refresher on how composite SLAs are calculated today. Now, I'm going to start with running my service in Cloud Run. It's nice, it's easy, it scales well, it's a fantastic service. That service is going to come with an SLA of 99.95%. Great. Now, if I was trying to calculate my composite SLA and it's just a single service, that's the composite SLA. It's just 99.95%. That is totally not realistic. Basically, nobody is running services like this today on GCP because maybe I want to do something like front it with a load balancer. Why would I do that? Well, I'd probably want to serve a certificate related to my domain name. So in order to do that, I'm going to be putting a load balancer in front of it. So I've got my global external load balancer. That's going to have an SLA of 99.99%, so 4 nines SLA. Then I want to have my Cloud SQL instance because I need to store something in a database somewhere. I'm going to use Postgres because that's sort of becoming the standard for relational databases these days. That's going to have an SLA of 99.95%, assuming I turn on HA mode and I'm using the Enterprise version, not Enterprise Plus. Now, I'm going to also assume that I want to communicate to this over a private IP address. I do not want to have a public IP. So how do I get Cloud Run to interact with Cloud SQL over private IP addresses? Well, I would have to go use something like serverless VPC connector. For now, they are working on a direct VPC access feature that's in public preview. I can't wait for that to be GA and available in all the different regions. But for now, it's a serverless VPC connector. And they don't publish a specific SLA for this, but you do have to run a VM. You pick a machine type in order to support this service. It's going to be spread across multiple zones. So I'm going to assume that this has an SLA very similar to if you ran a Compute Engine VM in multiple zones. So 4 nines SLA. Okay, now because from a user perspective, I need all 4 of these things to work. I need the load balancer for the certificate. I need to have Cloud Run for the compute, the VPC connector to connect to Cloud SQL, plus the Cloud SQL instance in order to feed the data back to the service. These are what's referred to as a tightly coupled service. How would I calculate the composite SLA on this? Well, the formula is pretty straightforward. I would do 4 nines for the global load balancer times 3 nines 5 for Cloud Run, and then I would do 4 nines for the serverless VPC connector, and then finally I would go in there with 3 nines 5 for Cloud SQL. Now, the trap here that people fall into is they will look at all the individual services and then they'll say, well, I'm using nothing less than 99.95%, so therefore that's my SLA. I can expect everything to be up 99.95% of the time. That is totally not the case. You cannot depend on that because you are actually saying all of these simultaneously need to be up at the same time. So what are the odds of that? Well, if we take this formula, we run it through, what you'll see here is that the actual composite SLA is now 99.88%. So, okay, well that's still pretty good. You know, I got 2 nines. So what does this actually mean in practice? Well, we can use the uptime calculator. and we can say 99.88. What can we expect now? We can expect that every month that this service will be unavailable for 52 minutes. Now, it might be more, it might be less, but you should reasonably expect it to be down for at least 52 minutes in a given month, or at least plan on it in terms of what you're basing your SLAs or SLOs on. So 99.88, let's just take a couple notes here. 99.88% means 52 minutes in a month. Okay, well, this is fine, maybe not, but we want to start tackling the question of, well, then how do I go about improving this? Well, okay, let's break apart a couple components in order to try to make this number a little bit better. So we are going to start with the same foundation that we had before. Let's move it down here so we've got a nice little clean workspace for us to work in. Now, we're going to put this off onto the side. So this is going to have that 4 nines that we talked about before, but I'm going to start introducing multiple regions into the mix. Our load balancers can be global. The VPCs are global on GCP. So let's assume that everything within this box is going to be sitting in, let's say, US Central 1. Let's move that over there. Fantastic. I'm going to move all of my services into there. And I'm also going to specify that this is the primary instance. So anytime I want to be able to do write requests into my Cloud SQL database, I got to hit this specific instance. But we'll get into kind of the problems that this introduces in a little bit. Now, let's say I want to add in the second region. Well, okay, I'm going to go in here. I'm going to take all of this stuff. I'm going to duplicate it. But let's put this in Europe. So this is going to be in Europe West 1. I'm going to have my Cloud Run service again. But I can't have 2 primaries with Cloud SQL. At least the Postgres version, as of recording, doesn't support multi-master replication. So do I accept the latency hit at any time I have to do a read request or a write request to the database? Well, ideally not. So what I'm going to do is I'm going to introduce a read replica into the region. Okay, great. But then we get to a bit of a problem here, which is that let's say a request comes into the load balancer. It might be sent to US Central 1, or it might be sent over to Europe West 1, just based on, is the service healthy and it's available. So if my application is going to live entirely within Cloud Run, I need a way for my application to understand, where do I send my write requests versus my read requests? Well, how would I go about doing that? Well, I can introduce another service into the mix. We can use PG Bouncer. PG Bouncer is a connection pooler for Postgres, but one of the advantages is you can have PG Bouncer set up to point to multiple Postgres instances, and then in your application logic, you can decide which database do we actually want to be using at the end of the day. So PG Bouncer can optionally send requests to a read replica within the region where the application itself lives, or we can decide to send some of those write requests over to the primary instance that sits within an entirely different region. So this is a good example of where those global VPCs lets us do this with very minimal effort on our side. Now, I want to keep my application logic the same, right? I don't want to, if the request comes into US Central 1, I don't want to have like separate logic for how do I handle PG Bouncer or anything like that. So to simplify my application code, what I'm going to do is I'm going to take PG Bouncer and my Cloud SQL read replica, and I'm going to recreate that same pattern over in US Central 1. So PG Bouncer could optionally send requests to the read replica within US Central 1, or direct it back to the primary instance if it's a write request. So great. Now my application is being spread across 2 regions. I didn't have to introduce a caching layer. I didn't have to learn how to use another client library. I'm just saying, from an application perspective, sometimes write requests go over here, read requests go over there. Now you might be thinking, well, why would I, in my application logic, decide to send read requests to the read replica and write requests over to the write replica? Wouldn't I want to have a separate Cloud Run instance that maybe handles my write requests versus a separate one that handles the read requests? And you can do that. And that's where you're starting to get into more of microservices type design. For now, we're just going to assume that we're kind of in this monolithic state. So unfortunately, we're going to move some of that complexity over to the application developers. But they got to be very conscious in how they write their code and which type of database is a request going to be sent to. So now let's start filling in what our SLAs look like. So again, we have 3 nines 5, 4 nines. One service we haven't considered before yet is the PG bouncer instance. Let's do a worst case scenario and assume that this is just going to sit within one single zone on GCP. So that's now a 3 nines availability. And the Cloud SQL read replica, as long as it's in HA mode, is going to have the 3 nines 5 SLA like before. So just to make this nice and easy to read, let's move all of that down here as well. So these are the new services. These are the new SLAs that I'm going to be dealing with going forward. So now the question is, I've got all my SLAs. I've now split this apart into 2 regions. How do I determine what my composite SLA is? Did we actually meaningfully improve our reliability? To answer this question, we really want to focus on what it looks like from a user's perspective. If I'm a client, my request hits a load balancer. It could be directed up to Europe West 1, where it hits Cloud Run, hits the serverless VPC connector, hits BG Bouncer, and let's assume it's a read request. So it's going to hit the read replica that exists within the current region. Okay, now what could also happen? Well, I could hit that load balancer, and then I could be redirected to US Central 1 through that VPC serverless connector to PG Bouncer to the read replica. So I've got a bit of an OR statement, right? Now how I want to calculate this is based on the odds that both Europe West 1 and US Central 1 would both be down. So the formula looks a little bit different, but it's not too difficult. Let's start our calculation with just a general regional component, right? So first we start with Cloud Run with the 3 nines 5. Then it hits a serverless VPC connector of 4 nines. Then it hits PG Bouncer with 3 nines. And then finally, it hits the Cloud SQL read replica at 3 nines 5. Okay, so that's the composite SLA of the regional components for a read request. Okay, but we want to calculate what are the odds that both Europe West 1 and US Central 1 are both going to be down. So we can take 1 minus, so 100% minus the composite SLA, and then that's going to be the odds that an individual region will be down. Now, we're going to multiply that by the product of 2, because we have 2 regions, so what's the odds of both of them are going to be unavailable at a given time? And then we subtract that from 100%. And that's going to give us the SLA of the regional components. Now let's take a look at what we've got so far. If I take this formula and I go to calculator, we will see that the read components have an SLA of 5 nines. That's awesome. You think that's great, but that's not actually true. Let's take all of that, wrap it up, and then also multiply it by 4 nines for that global load balancer, right? So it's the tightly coupled service over here with an OR statement of either 2 of those options will suffice. And then this is going to give us our composite SLA for a read request. So where are we at now? Perfect. We are now at 3 nines 8 9. Okay, so read requests, our composite SLA is, let's see, for composite SLA is 3 nines 8 9. All right, let's take this and let's take a look at what this actually means from a practical perspective in terms of like uptime itself, right? Okay, so remember before we had 52 minutes of downtime every single month. Well, what do we get now? We can see that our monthly downtime for a read request suddenly dropped down to 4 minutes and 47 seconds. This is a big improvement from our previous single region design. Great. So we're thinking we made a huge improvement. Our reliability is much better. Okay. And in some ways it is. Now, that's just the read requests. We've got this funny situation now where the primary instance, anytime we want to do a write request, how do we incorporate this? So let's walk through those requests again. Okay. Now instead of us following the read request, we're going to follow the write request. So it goes in through the load balancer, hits the Cloud Run service, the connector, the PG bouncer instance, but then it has to finally go down to the Cloud SQL instance sitting in US Central 1. And again, that load balancer might send requests to Cloud Run. So there's an OR path of going to this instance of Cloud Run to the VPC serverless connector to the PG bouncer, but then ultimately it's now going back to that very tightly coupled single instance of Cloud SQL. So what does this look like from a calculation perspective? Well, it's going to look more or less the exact same, except with the difference of we're going to remove the SLA from the read replica, and then we're going to add that in at the end, right? Because now it's a tightly coupled component, so 3 9 5. So if we take this formula and we go back to our calculator, we will see that now we are at 3 9s 3 9. Okay, so this is better, but what did we actually get here? I'm going to make a quick note here that our write requests Composite SLA is, that's nice and messy. Take that out, 99.939%, perfect. Okay, so let's take that percentage, put it back into our uptime calculator, and then now we're at 26 minutes and 31 seconds of monthly downtime for the write requests. Let's look at where we started from. Now, originally, we were saying we're going to have 52 minutes of downtime in a given month. Okay, well, we've made it better. The read requests are demonstrably better. Like, it's less than a tenth of the expected downtime for our read requests. But we get very diminishing returns when it comes to the write requests. The twist here is that certain architecture choices are going to be very difficult to improve the reliability on. If you're using Cloud SQL as your database, as it stands, you're very much dependent on that single primary instance being available within a single region. If you want to improve your write request composite SLA in a very meaningful sense, it becomes really difficult with Cloud SQL as the option. This is typically when customers come to us and say, I'm willing to consider something like a Cloud Spanner, because let's walk through this same architecture again from the perspective of using multi-region cloud-native solutions. So I can come in here and I can say, again, we've got our global external load balancer. That's going to sit at 99.99%, like before. We're going to have, let's say, 2 regions currently running. And within that, we're going to have Cloud Run sitting again at 99.95%. Let's move that box down. And I'm going to say, let's use the serverless VPC connector because we want to access resources within our VPC. This is going to be sitting at 4 9s. But the difference now that I'm going to propose is let's not use Cloud SQL, let's not do read replicas, let's not use PG Bouncer at all. And instead what we're going to use is we're going to choose a database solution that lets us span across multiple regions. So this could be our spanner instance. Maybe let's move that up. So I have a single spanner instance. I'm not dealing with separate instances. It's all just one logical unit from my perspective. And then spanner is going to have an SLA of 5 nines when it's a multi-region instance. And maybe what I also want to do is introduce caching instead of using a read replica for those read requests. So I can go in there and I can say, you know what? I'm going to use something like not memory store, because memory store is going to be single region, but I'm going to use something like Redis Enterprise, where if I use the multi-region active-active layout of Redis Enterprise, again, I get 5 nines of availability. Okay? So we're going to copy our Cloud Run and our serverless VPC connector now to a second region. So when we try to figure out what the composite SLA of this is going to be, it's still very similar. Like the write requests are going to have a separate path, the read requests are going to have another path. Okay? So what's the composite SLA of this solution going to look like? Well, let's steal the formula that we had before. Now, how do I calculate the composite SLA of this new service? So let's start with that same formula that we had before, where we had the global load balancer, Cloud Run, the VPC connector, but we're going to remove PG Bouncer now because we don't actually need to have that. And let's take it from the right perspective path, which is that we now have 5 nines of availability. Okay, let's take this formula, go back to Wolfram Alpha, we run the numbers through, and what you'll see is we now have 39889 of availability. That's pretty darn good. And that's for our write requests. Perfect. Things are looking better now already. Now let's go see what this actually looks like from a practical perspective of uptime. So we go through, and now our write requests are down to that sub 5 minutes of downtime in a given month. As you can see, this is a already huge improvement of availability for any of my write workloads. But now let's look at it from the perspective of my read requests. What does that look like? I'm going to take this same formula, because it's going to be mostly the same. What I'm going to do is I'm going to copy the same odds that it's unavailable logic. I'm going to put that at the end because my read request can be either serviced by Cloud Spanner or it can be serviced by Redis Enterprise. And both of those have a 5 nines SLA. So when I run this calculation, we get $39899 again of SLA. So a little bit better than not the read request. So we're looking at a little bit better than our write requests, but you're starting to see we're really getting to very diminishing returns. We're starting to hit the ceiling of how reliable our service can possibly be, especially with the load balancer being the 4 nines of availability. But we're now looking at 4 minutes and 23 seconds of potential downtime for our read requests. And I realized I forgot to write down the write request SLA, so we're going to just jot that down too. So the takeaway I want you to have from this is that our read request composite SLA, when we use Spanner and Redis Enterprise, it's pretty darn close to our read requests. If the matter of 20 seconds is important to you and you're willing to spend the money on it, by all means. But if you wanted to improve the write requests SLA, it did require us to go to an entirely different platform, aka Spanner, in order to make a dramatic dent on our write requests. But fundamentally, we were able to hit really similar-ish numbers with our read requests. And we could improve that further by using maybe AlloyDB, Enterprise Plus, load balancing our PG bouncer instances behind HA proxy. There's a lot of options that we have available to us, even with previous architecture. So I hope you enjoyed today's video, and I hope you got 2 takeaways from it. Number 1, there are very affordable constructs that you can use to improve your service's composite SLA. And number 2, it's not about trying to find a single number that perfectly represents your service's availability. It's about figuring out the different patterns that your users have with your services, and then deciding what is your availability for that path and which are the ones that you want to invest in further. In the future, I'll dive in deeper on what it looks like to run these global distributed services like Spanner and Redis Enterprise. Like and subscribe, and see you next time.